Other thoughts? 2.8. That's a big difference. Everybody check it again. Nick?
What?
2.8, 2.9. What do you guys want? I would go 8 because it's easier to divide by 2, but that's just me. So if we divide it in 2, what were the 2 halves? Can we agree on that? The third one? 3.5. Sorry, Jess? 3.2. Okay, if we divide it in half. Okay, we're good with those measurements. Join those midpoints to the center. And then I went to get my protractors to have you measure the angle, and somebody took them. They are all gone. The drawer is empty. I think we have a protractor thief. So you'll just have to believe me, it's 90 degrees, and 90 degrees, and 90 degrees. Nope. And so here's the only chord property we're going to study, the something radius. But what do we call 2 lines that meet at a 90-degree angle? Think back to our vocabulary. Perpendicular, so we call it the perpendicular radius. The perpendicular radius to a chord bisects the chord. The perpendicular radius to a chord bisects the chord. What does bisect mean? We looked at that in our vocabulary. 2 equal halves cuts it exactly in half. That's why all of these go right through the midpoint. That's the only circle property for chords that you need to know. And what we use this for more often than not is to find the center of a circle when it's not marked. So what we're going to do second is we're going to draw 2 congruent chords. We're going to draw the perpendicular bisector of each, and then we're going to mark where those 2 lines cross. So I'm going to do 1 chord on the left and 1 chord, no, I'm going to do 1 on the bottom. And it doesn't matter how long you make it as long as your 2 chords are going to be the same. So I'm going to make it a nice measurement. Let's do it 4. Okay, so I just put wherever the ruler happened to hit 4. And before you move your ruler after drawing the line is mark the midpoint, so mark where it's 2. Didn't have to be 4. I could have done it lower down, done it a shorter measurement, moved it up, done it a longer measurement. Doesn't matter. Then we need to do another one that's forward, so I'm going to go to the side, left, right, I don't care. So find exactly where it cuts at 4. Again, before you move the ruler, mark where the midpoint is at 2. And it doesn't matter where you put the 2 chords. I wasn't trying to get these to be perpendicular. It doesn't matter if one's slanted, one's not. One could be at the top, one could be at the right. Doesn't matter. You just start with 2 congruent chords, so 2 chords of equal length. Now we have to draw what's called the perpendicular bisector. And the easiest way to do something that's perpendicular when you don't have a protractor is put the bottom of your ruler on that line and put the edge right at the tick mark. And we know that the corner of a ruler has to be 90 degrees. Then use the other end. So use the edge of your ruler and where it crosses, and I'm just drawing that line there. There's no particular length. I drew it because I'm going to chop it off in a second. And the trick is this just needs to be a 90-degree angle on that chord. It's called the perpendicular bisector. Perpendicular because it's 90 degrees, bisector because it's going through the midpoint. And I'm going to do the same thing on the other chord. So use the edge of your ruler to get a 90-degree angle. And how does that help us get the center? Because where they cross has to be the center of the circle. Why? Because they're called? They're called? They're radii. So if you look on the chord, there's only going to be one line that's going to cut this exactly in half. There's only going to be one spot that's half. Now I could technically draw a line of any angle, but there's only going to be one line I can draw that's exactly 90 degrees. So there's no other spot in this line that I can cut it in half and draw a 90-degree angle. And the property says that one line is always going to be a radius. So what do you know about the radius? Goes through the center of a circle. Find the center on this one for me. Not at all. Not at all. If they're exactly opposite each other, it's hard to see where they intersect because they kind of line up on top of each other. So I never do them top and bottom or left and right. I always do one top and bottom, one left and right. Yesterday, they're going to give you a diagram with a bunch of stuff. They're going to give you some information and ask you to find something else. Note, just like yesterday, these are never drawn to scale. So these are not measure and get the answer. They're not drawn to scale. You cannot just measure and write that down as the answer. Kayla, take your earphone out, please. Number 1, center with circle O shown. CD is 48. OM is 18. What's the length of the diameter? What do you want to do first? Okay, what do you want to mark? Oh, I wrote O to M wrong. Should only go to M. O to M is 18. There we go. But we don't have the diameter. We don't have the radius. So I talked about yesterday's look for the shapes. Look for arrowhead, look for bow tie, look for semicircle. For this one, it's fairly easy because you're looking for a chord. These are one of the few that are going to have chords. So the minute we have a chord and we have a line that's perpendicular, what do we know? Well, number 1, we know this is the radius, but what else do we know? What does that perpendicular radius do? It cuts it in half. So I know that CM is the exact same length as MD because that's what the chord property does. It cuts it in half. So if the whole thing was 48, what are each of those halves? These types of questions will always work this way. I'm going to add one more line that's not in the diagram, and you have a choice where you want to add it. I'm either going to add O to C or I'm going to add O to D. Completely up to you. Do you want to use C or do you want to use D? D. Okay? I'm going to add in the line from O to D. And I'm going to color this triangle just so it pops out for us. My 24 is kind of getting lost. There we go. What kind of triangle? Right? And if I have this side is 18 and this is 24, can I find that line that I just drew? Okay, what do you want to call it right now? We don't know what it is. Okay, so tell me what you know about x. Okay, 18 squared plus 24 squared has to equal x squared. Why, we should give you little magical calculating machines that you can hold in your hand. Sorry, what was the first one? Just looking for confirmation on those. Okay. Even? Offer of 30? So with this property, if you add in the radius, you'll always be able to find the length of it if you have these other two sides. But did that answer our question? What's the question? What's the diameter? 30 times 2, which will be 60. Questions so far? Lots of Pythagorean theorem in this unit, you've noticed. Number 2, circle shown with center O has a diameter of 20. If the chord AB is 8 from the center, find the length in centimeters of A to B. What do you want to do?
The line across O is 20
AB, we don't know.
chord AB is.
And right away you should see the chord property with the perpendicular bisector. So what do we know about AB?
Equal.
The two sides are going to be equal. So it kind of looks like the diagram above, except it's got a line straight across. What did we do in the last one? We drew a line. Where do you want to draw a line here? A to O or O to B, your choice. Do you want to use A or do you want to use B? Oh, I heard A first. Do we have a measurement for that length?
No, 8 centimeters is one of them.
Well, 8 centimeters is O to this part, but it's not that radius that we just drew.
No, we don't. Yeah, we do. It would be the radius, so we just have.
So if the whole diameter is 20, what do you know about the half of it? The radius is 10. What did we just draw? A radius, so it's also going to be 10. Now what? Bless you.
8 squared.
Well, 2 is just going to give us the diameter here, but is that what we want to find?
8 squared plus
So follow what we did here. Look at what we have here.
8 squared.
I've got 8. I've got 10. Do I have this bottom side? What do you put when you don't know something? Now the difference from above is I didn't have the hypotenuse. Do I have the hypotenuse here?
Yes.
Yes, because what is the hypotenuse?
It's the longest side.
Which is?
10.
10. It has to be opposite the right angle. So I know that x squared plus
64. Well, 64.
8 squared has to equal
10 squared.
10 squared.
So x squared equals 36. Or 64 equals 100.
Confirm 64 and 100.
X squared equals 36.
Okay, so 6. What did we find? Is that what we're looking for?
No, you're all right.
That's just the halfway point. So what's the length of AB? Has to be 12. Give me some units. Centimeters. It's the exact same question as above, except this time we didn't have the chord, but we had the radius. Here we had the chord, but didn't have the radius. We just worked backwards. Turn and talk. Find a friend. Work on 3 together. We'll talk in a couple minutes. Talk. Step 1. What do you want to do?
Draw the line from
Where would you like to draw the line?
O to A.
Does it have to be from O to A?
No.
Where else could it be?
B to O.
Why?
Because they're equal.
How do we know these are equal?
Because it's cut in half.
Because the perpendicular radius Look back at the property, the perpendicular radius bisects. This is painful. The perpendicular radius bisects the chord. That's how you explain it. The perpendicular radius bisects the chord. Carter! Now what?
You can label that B to P is also 4. Now you go 4 squared plus 2 squared. This is x squared and O to A is x. 16 plus 4 equals x squared. 20 equals x squared. 3. No, 4.5.
Confirm 4.5.
And then multiply by 2.
Why?
Because it's only half of the diameter. 9.
We've got an answer of 9. Awesome. Question so far. Do you see the similarity so far? You see it? Let's take one where the diagram looks a little bit different. Tons of stuff going on in here. Where do you want to start?
Well, the triangle already showed it for us.
Okay.
Do we have to show it's a right angle or do we need to?
Well, let's see first what the question's asking us for.
CB. What the length is CB?
Okay.
Yeah, so we gotta go multiply 8 by 2 first of all.
Why?
Because it's only half the perpendicular line of the chord and half
Okay, so you want to find the length of AC. Okay.
8 or 16, sorry.
The diameter,
Why do we need to find the diameter?
because we want to figure out CB.
How do we know this is a right angle down here at C?
It's 90 degrees.
This is the semicircle property here that says this is going to be 90. So if we can find the diameter, then we can find CB what we want. Do we have the diameter? How can we find it? So this one's actually combining the two properties. We're going to first use the chord property to find AO. Then we're going to use,
Chord property.
no, what property? Semicircle property to find CB, so two-stepper. So step number 1, we're going to use this little triangle here with our bisecting radius. 6 squared plus 8 squared. Now we can't call it x because I've already written an x over here. We can call it y. We can just call it AO if you prefer, whatever you like.
100 equals what? Rooted equals 1 or 8.
So we know A to O is 10.
That means A to B is 100 or 20.
How do we know A to B is 20?
Perpendicular line.
And so just so you can see the new triangle we're going to use, we're now using this big triangle. That semicircle property.
So now you go 10 squared.
Just slow down a bit. First thing we want to do is determine what's the hypotenuse, because that changes what's in our formula here.
Longest side.
And which one's the longest side?
A to B.
A to B is the longest side. So the other two, we have x squared plus 16 squared has to equal
10 or 20 squared. X squared plus 256. Yeah, 456.
Somebody confirm the values?
Yeah, 256.
Okay. Are we done, or do we need to multiply by 2 like we did in the last one? How do we know we're done?
It's on the length.
Because that is CB, so 12 is the final answer. Number 5 with a partner. Okay. Tell me your thoughts.
18.4. That's just my thought. It's 14.4, dude. What?
And 14.4.
18.4. You're on freeze.
Oh.
You gotta first go x squared plus 12 squared equals 14.
Ooh, where's that coming from?
O to D is the radius, which is 14.
Okay.
And then you got, so that means O to C is the same thing.
So you want me to draw a line from O to C?
Yes, please.
Does it have to be from O to C?
No, it can be O to A as well. You're on freeze.
Oh, still on freeze. Okay.
Then you gotta go
To the chord.
Which is 12.
Why is that 12?
Because it's same as the radius, but there's 2.
Yeah, so that's a tricky one. Some people might have missed at the beginning. Still a radius, so if this is 2, this has to be 12.
you gotta go 12 squared plus x squared equals 14 squared. 144 plus x squared equals 196. Subtract 144 on both sides, which would get you to 52 x, and then root it 7.2 multiplied by 2. You gotta multiply by 2 now.
Why?
Because it's only half of it, you gotta figure out the full
Because the perpendicular
line.
radius bisects the chord. So total has to be 14.4. Who got it? Awesome. Questions? Do the last one. Find me the bullseye.
Actually, sick. I found the bullseye. What do you mean? Found it.
Good.
Yeah.
Not using chord property.
But I still found it.
How do you know that's exact center? You have no idea.
Because it, like, looks like it.
Aha. Use the chord property. Brody, what are you doing? Jordan all done? David all done?